This
Okay.
conference will now be recorded.
Okay. So far we have been discussing only on compute related services. We discussed EC2, we discussed light sail, but now we'll start discussing something new, which will be around network. Okay. So network is very important when it comes to any cloud technology. Okay. So in AWS network, we call it as virtual private cloud. Okay. VPC stands for virtual private cloud. So there are a lot of customers that will start running their services on AWS, right? And everyone will look at having some isolation or some kind of segmentation for them. So they would like to have a separate network, isolated network for running their resources. So in such cases, we need to have the EC2 instances or the resources created in a separate VPC. Okay, so VPC stands for separate network or private network in AWS. So with VPC, you can provision resources. When I say resources, it can be EC2 instances, it can be any AWS resources. We will provision the resources in a logically isolated section in AWS. Okay, so we can just call this as virtual network dedicated to a particular customer or to a particular client. Okay, so VPC is a separate virtual network. So why we need to do this? So we need to have a separate segmentation or separation or segmentation or isolation. So VPC can help you to have a completely separate environment. So if you create a VPC, you can have your own IP range, IP address range. You can have your own subnet created. I'm not sure how many of you have heard about subnetting, but I'll give you some couple of examples on how to do the subnetting and how to use that in the cloud. Okay, so if you're creating your own VPC, you can have your own IP address range. You can have separate subnet. You can have control on complete networking. Okay, so VPC is the networking layer, and this is the networking layer for your EC2 and all the other services. Okay, now let's go and create a network here in the AWS platform. So in order to do that, you have to go to VPC. Either you can select it from your favorite, or you can go to services. Under the services, we can go and select the networking and content delivery. And here you can go and select the VPC. Okay, so either you can go and select it directly on the favorite, or you can just go to the services and log in there. So if you look at here, you have got multiple services or multiple sub option within the VPC. So here, as of now, by default, every region will have a default VPC. Okay, that is the reason you are able to create resources in AWS even without creating a VPC. So whenever you go and create a new instance, it will get created in the default VPC. For example, I'll show you in other region. For example, if I go to Paris or Stockholm or any region, okay, so there will be a default VPC in all the region. Okay, so you can see that there is a default VPC. Okay, and there is a default subnet also. So your VMs will get created in the default VPC and default subnet. So default VPC, there will be one default VPC per region. Okay, so by default. Okay, and you will also have one subnet for each and every data center. So if you look at here, 3A, 3B, and 3C. Okay, so each data center will have its own unique subnet. There will be one default subnet per availability zone. Availability zone is data center. Okay, for each and every data center, you will have one default subnet created by default. And there will be a default route table also. So route table is for restricting where exactly the traffic can go and where exactly the traffic cannot be routed and so on. So you'll have a one default route table also. So with virtual private cloud or with networking, you'll have better isolation, better segmentation, and also you can use this networking to communicate with internet, and you can also communicate that with within your AWS or to your on-premises data center. So you can use it for all communication purpose. And I'm not sure how many of you have heard about the RFC 1918 documentation. So RFC 1918 documentation has the complete details of IP addresses that can be used in the public internet space and the private IP address space. So RFC 1918 is the document for address allocation for private internet and all those things. So here, if you look at the documentation, this is the document which will be used for IP address allocation globally. So if you want to go and assign an IP address, it has to fall in a specific range. Okay, so there are 5 different classes of IP addresses, right? Class A, Class B, and Class C, D, and E. So out of that, okay, we can use certain IP addresses for specific purposes. Okay, I'll explain a few more things here. Just a second. So let me open up this RFC 1918 document. So if you go through this documentation, you can understand which range you can use it in uh, the environment. So these are the ranges that you can use it in your organization. Okay, so there are 2 type of IP addressing, right? Public IP addresses and private IP address. So for private IP address, this is for internal organization use. Okay, and public IP addresses used in internet, public internet. Okay, so if you want to use any IP address within your organization, so this is the only range that you can use. Okay, so the IP address is starting with 10 and then 172 and then 198, 168. So this is the only IP range that you can use from the entire IP addressing. Okay, Class A, Class B, and Class C. So now scrolling down. So remaining all the IP address, you can use it for public IP addressing. So I'm not sure if you have heard about this organization. So this is the organization that maintains all the IP address spaces. Okay, Internet Assigned Numbers Authority, IANA. There is another organization called ICANN. Okay, that is Internet Corporation for Assigned Names and Numbers. They take care of both naming as well as numbering. Internet Corporation for Assigned Names and Numbers. So both naming as well as the numbering will be maintained by this ICANN organization. So IANA stands for Internet Assigned Numbers Authority. They are the one who make sure which IP addresses can be used within the organization for internal use and which ones can be used on the public internet space. So there is another organization, IANA, which stands for Internet Assigned Naming Authority. Naming is for domain name. So this organization maintains both domain names and as well as the public IP addresses, numbers, and all those things. Okay, so if I want to create some subnet within AWS also, I need to use only these 3 range. So if your organization is very large, large to very large, you can use the Class A IP address. Class A IP addresses provides you very large suffix, so you can have lot of IP addresses here. Similarly, if I'm belonging to medium to large, I can use the Class B IP address. And if my organization is very small to medium, then I can use the Class C range. Okay, this is how you have to use it. So if your organization is very large, then you have to use the Class A 10 range. If your organization is very small, then you can use the Class C range. For example, in your home network, or if you go to browsing center, you will see this 192.168 IP address. Even in this Advantage Pro location, you can see that they are using 192.168 because they are under the category of small to medium. If you go to office location, you can see that most of them will be using 10 or 172 range, because they need lot of systems, lot of network connections and so on. Okay, so the 192 range is mainly for small to medium size organizations. Okay, so scrolling down, I'll explain few more things. Okay, let's see how to do a subnetting now. Okay, I'll give a couple of examples. Okay, we'll see an example for subnetting now. Okay, I'll clearly explain how we can derive the subnet, how we can derive the subnet mask and all those things. Okay, suppose let's take like we need to start an organization like Precision VNet. Okay, so we have to decide how many IP address we need to have for the entire organization. Okay, maybe if we are a startup, okay, let's say let's take ABC VNet. Okay, so ABC VNet has to have let's assume they need to have some around 300 or maybe 200 IP addresses. So how do we derive that? So when I say 200 or 150 IP address, one machine can have more than one IP address, right? So you should not count by the number of devices. Instead, you should understand how many IP addresses are needed for the overall organization. Okay, let's assume some organization will segment their environment by role of the server, or some people will segment their environment by the environment type. For example, they will have development subnet, they will have uh, QA subnet, and they will have production subnet. And some organization will have a web subnet, app subnet, and database subnet. So it depends on organization to organization how they want to segment their IP address schema. Okay, so let's take this first example with development, QA, and production. So just for an example, I want to have maybe I'll say I want to have 20 IP address in my development subnet, and I want to have 40 IP address in my QA subnet, and for production I need 100 IP address. So let's take this as an example. Okay, and here with this example, generally in subnetting we have a formula which is 2 to the power of n. Okay, so this is the formula that we generally use. Okay, so 2 power 0, anything to the power of 0 is 1. So 2 power 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2, 4, 8, 16, 32. I'm just doubling the number here. I'll just write only up to 256. I don't think we need beyond that, because the requirement is very small here. Okay, so 2 power 3, 2 power 4, 5, 6, 2, 7, 2 power 8. 9. Okay, so let's keep this. Okay, now, okay, so whenever you have a IP address requirement, we need to tag them to the 2 power n formula. So here for 20 IP address, which one will be the sufficient one? If I go and choose this 2 power 4, then it has got only 16 IP addresses. This might not be sufficient. So, and if I go and choose 2 power 5, it has got 32, it will be sufficient. See, anything beyond this number is sufficient, but generally you should not go and choose something which is very large. The reason I say that, for example, if you take 1024 as an example, then you will have 1024 IP addresses assigned, and the machine or whenever there is a new allocation that has to happen, it will go and have a very larger broadcast domain. It will have to go and scan all the 1000 IPs before assigning that IP address. So the time taken to assign a new IP address or make a decision, it will be longer. So you should not always go for a larger number. You should try and limit the allocation to a closest number. See, it can be either 32 or it can be 64. You should not go and waste a lot of IP address, or you should not create a bigger broadcast domain. Creating a bigger, larger broadcast domain, it will unnecessarily create delay in the packet transfer, delay in communication. So in order to shorten the communication, you have to choose the nearest number. So I'll choose 2 power 5 here, okay, which is the closest number here. And for 40, I can choose 64 or 128. I'll go for 64. Okay, you can also go for 2 power 7 to have some buffer for future expansion, okay, if you want to. And here I'll choose 2 power 7. Okay, now I have got the 2 power n formula equivalent. So what I've done is I've taken the IP address total requirement and I've matched it to the nearest number that I have here. Okay, so that is what I've done. So now next, in general, all the public cloud vendor, either AWS or Azure or any provider, they will reserve 5 IP addresses in every subnet for the router requirement, for the DNS IP address, for gateway, for broadcast. They will reserve 5 IP addresses in each of the subnet. See, for example, I'll tell you. Okay, let's take one particular subnet. So if I'm assuming that I'm going to use 10.x for my requirement, in this 10.0.0.0 is always first type address is always network address. It cannot be used for system. And then the next address is reserved by AWS for the default gateway. Okay, so that is nothing but your VPC router. And the next IP address 10.0.0.2 is reserved by IP address, reserved by AWS for services like DNS and so on. Okay, the next IP address will be 10.0.0.3 and it is reserved by AWS for any future usage. Okay, and the last IP address in the subnet, which is nothing but your 10.0.0.255. This is your broadcast IP address, network broadcast address. Okay, this is also reserved actually. So in each subnet, you will have 5 IP addresses that will be reserved by AWS or Azure or any provider. They will reserve the 5 IP address in each subnet. Okay, so now let me add that 5 reservation subnet here. So in each of the subnet, you'll have 5 addresses reserved. So I'll also include that into the calculation here. Okay, if I include that, I'm just adding 20 plus 5. That is the requirement, right? So for the customer devices, for the system, you need to have 20, and I'm reserving 5 IP addresses for the cloud reservation. So in total, it will be 25 here, and this will be 45, and this will be 105. That is what I have in total. Okay, this is the actual requirement. Okay, now I'm just going to derive what are the number of IP address that I'm going to have. So here 2 power n is how much? 2 power 5 is 32. I'll have 32 IP address here. So 2 power 6 is 64 IP address and 2 power 7 is 128 IP address. So I got these many IP address. For I have got 25 IP address that is needed, but I've got 32 IP address, which is more than enough. Right? I've got 45 and here it is 64. Yeah, it is more than enough. and I got 105 and 128 IP addresses are available, then it is also good actually. So now I've found out what kind of IP addresses I need. And now I'm just going to find out the CIDR value. CIDR value stands for classless internet domain value, or they call it a subnet mask. So CIDR value, classless interdomain routing value. So we need to find out this CIDR value. Is called as classless interdomain routing value. So I'll find out how to do that. Okay. So in an IP version 4, how many bits are there? In an IP version 4, we have 32 bits, right? That is the thing we have. Okay. So we'll have 32 bits. We'll have 4 octets. Okay. So 4 octets means each octet will have 8 bits. One octet is 8-bit. We have 4 octets in a IP version 4, right? So in an IP version 4, we have 4 octets, and here we need to find out how many we are going to use it for network and how many we are going to use it for host or the system. Okay, let me explain it here. Or else it's pretty straightforward, simple. I'll make it simple. Okay, so here I have got 2 power 5. Okay, and in an IP version 4, we have got total of 32 bit, right? 32 minus 5 is how much? 27, right? 32 minus 5 is 27. So that is the number that is CIDR. Okay, /27. Similarly, 32 minus 8 is how much? 26. So 26 is your CIDR. Similarly, 32 minus 7 is your 25. So 25 is your CIDR. Okay, I'm just subtracting the 32 number minus the formula that we have taken, 5, 6, and 7. 32 minus 5 is 27, 32 minus 6 is 26, 32 minus 7 is 25. So that is the CIDR value. Okay, so CIDR value. So in generally, in an IP address will look like this, right? 10.10.20.21, something like that. So here we'll have 4 octets, and 1 octet is equal to 8-bit. Total of 32-bit will be there in an IP address. Okay, just for an example. So now I need to find out how many usable IP addresses for each subnet. Okay, so I'll just find out how many usable IP address. So in this particular subnet, I've got total of 32, but if I subtract 5 IP addresses from that count, okay, I'll have only 27 IP addresses, usable IP address. Because out of the 32, 5 will be reserved by the cloud provider. Similarly, out of the 64, 5 IP address will be taken by the provider. So I'll get only 59 usable IP address. Similarly here, 128 minus 5 is 123. So I'll get only 123 usable IPs here. So now let's go and take a particular range. So either you can take the range of 10, or you can take the range of 172 or 198, 192. So maybe like we need a very small to medium one. I'll take the 192.168.0 range. Okay, so here I'll just go to 192.168.0 range. And here what I need to do is I need to add the CIDR value. So CIDR is 27. So this will be /27. And I'll find out what is the first IP address here. So as I told you, all these IP addresses will be reserved by cloud provider. The very first address is network address. What is the first address here? 192.168.0.0 is the network address. Then for the default gateway, they will use the first IP address, 192.168.0.1. And for the first reservation, it is 192.168.0.2, and the second reservation it is 0.3. Okay, so there will be 2 addresses. And what will be the broadcast? Broadcast will be the last address actually. Okay, so how do we find the broadcast address in this particular range? How many address we have got? We have got 32, total of 32. Since the number starts with 0.0, it will end up with 192.168.0.31, because it is like only total of 32, right? So it will be 192.168.0.31. So since it started with 0, I'm ending it with 31. If I started with 1, it should be ending with 32, because like total of 32 IP addresses are there in this particular range. Okay, similarly in the QA subnet, so the next IP address will be 32 here, right? It will start 192.168.0.32. Then the next one is 33, which is for default gateway. 34 is for again reservation 1. 35 is for reservation 2. And in this range, I've got total of 64 addresses. So which will be 32 plus 64, right? So the last IP address will be 192.168.0 dot. So I'll just do that. It will be 32 plus 63. Starts with 32, right? 95. So the IP address will end with 95. So totally we'll have 64 IP address in this range. You're having 64, right? It starts with 32 and it ends with 95. Total of 64 IP address. So when it ends with 192.168.0.95, this range will start with 192.168.0 dot maybe 96. Okay, so that's the way you have to create it. Okay, so next one will be 97, 98, 99. All these will be reserved by AWS, and the very last IP will also be reserved by AWS. So broadcast. So it will be 96 plus 127, because we have got total of 128 IP address in this subnet, right? So which will be 223. The IP address will end with 223. Okay, this is how you can go and calculate the range of IP address and the broadcast IP. So now we are going to identify the subnet mask for this particular each of the subnet. Okay, so how do we find the subnet mask? So it is very straightforward. So in an IP address version 4, you have got 8 bits, right? So you can just take all these 8-bit number and you can write it from right to left. Okay, so 1, 2, 4, 8, 16, 32, 64, 128, right? You have got this number, right? You have to write that from left to right. Okay, I'll just start writing it. 1, 2, 4, 8, 16, 32, 64, and 128. I'm just writing the same 2 power n formula from right to left actually. Okay, so here now I'll just add the subnet mask. I'll find out the subnet mask. So how many what is the CADR I've got? I've got /27 is my CADR. So /27 is my CADR, which is nothing but, let me cancel this. So how do I write this CADR in bit format, in 4-octet format? I can just go and write 8 bits dot 8 bits dot 8, 16, 24 and plus 3 bits. Okay, so 8, 16, 24, 27. I'm just writing the 27 number in octet format. Okay, 8.8.8.3. Total is 27. Similarly here, I'm writing the /26 here. Whatever I've got here, I'm just writing the same there. Okay, and this is again 8 bits dot 8 bits dot 8, 16, 24 and 2 bits 26. Okay, total of all this is 26. 8, 16, 24, 26. Similarly here I'm going to have /25. Okay, 8, 16, 24 and 1 bit here. Okay, so this is what I have got now. So if I want to write the equivalent of 8 bits, okay, total of 8 bits is how much? I'm just adding all this 8-bit number and I'm getting 255. Okay, so 120. Okay, let me check. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm just adding all these numbers. So if I add all these numbers, I should get. Okay, so there is a mistake here. So if I add all these numbers, I should get 255. Yeah, I'm getting the sum of 255 here. So 8 bits equivalent is 255, 255, 255. What is the equivalent of 3 bits? I have to just add 3 bits here. Okay, 1, 2 and 3 bit, and the equivalent of that is 224. So this is 224. Okay, similarly I have to write 8-bit equivalent is 255, 255, 255. What is the total of 2 bit? I have to just add these 2 bits here. Okay, 128 plus 64. The sum is 192. Okay, so this is 192. And similarly here I have to write 255, 255, 255 dot 1 bit. 1 bit equivalent is 128. Okay, this is how you can find out the subnet mask. It is very easy actually. Okay, this is how you can go and find out the subnet mask for each of your IP address ranges. So let's do one more thing. I know after lunch it will be a little tough to listen. We'll do one more example. Okay, subnetting example 2. Yeah, listen carefully. We'll just do one more example. Okay, let's say we are going to create it for XYZ VNet. Okay, so I'll just copy the formula here. Okay, to avoid doing the everything from the scratch, I'll just copy the structure. Okay, so I'll just copy this entire structure. Okay, now let's do one thing. Let's try to do one more example. Okay, for this company, I want to have three different subnet. So web subnet, app subnet, and I want to have DB subnet. So in this organization, they want to have segregation in application layer. Okay, web app and DB subnet. So now for application, web application or web server, they are asking for 50 IP address for an example. And for application, they want 20 IP address. And for DB, they need 10 IP address. So this is the requirement from the customer. Okay, and I want to create separate subnet for each of the requirement. So in total, for 50 IP address requirement, I need to choose the 2 power n value. So which one will be enough? I think 2 power 6, which is 64 IP address, should be sufficient, right? So I'll go and choose 2 power 6. So equivalent is 64. So 64 addresses should be sufficient even after adding the cloud reservation. So cloud, they will be adding plus 5. Right, so plus 5 will be added for cloud reservation in each of the subnet. Okay, plus 5 and plus 5. So here I'll get 2 power, which one will be enough? 32. 2 power 5 should be sufficient enough. Okay, similarly here 2 power 4 should be enough. Okay, 2 power 4 is 16 IP address. So this is neck on neck. The reason I say that, so 10 plus 5 is 15. So you have got only one buffer IP address. If you want to be lenient and if you want to expand in the future, you can go and choose the next one, 2 power 5 or 2 power 6. Okay, that shouldn't be a problem. That shouldn't be a big issue. Okay, so now let's do one thing. Now we need to find out the CIDR value. So how do we find the CIDR value? So total of bits in IP version 4 is 32 bit. 32 bit minus the number of bit that we need for our system will give us the network bit, which is the remaining. 32 minus 6 is 26. That is slash 26. Okay, 32 minus 5 is 27. This will be slash 27. Okay, 32 minus 4 is slash 28. Okay, I'm just doing simple mathematics here. I'm just subtracting 4 from total 32 bit. I'm subtracting 5 from total 32 bit. I'm subtracting 6 from total 32 bit and writing just that number here with just front slash. Okay, and we need to identify the total usable IP address. So how much is the total usable IP address? 64 minus 5 is 59. So I'll have 59 usable IP address here. Similarly here, I'll have 32 minus 5, which is 27. 27 usable IP addresses. Okay, similarly here, 16 minus 5, 11 usable IP addresses. Okay, let's do that. So now I can just go and choose a network range or a network address. Okay, so let me do one thing. First, let me define the range. Okay, which range I want to use. So for this requirement, maybe I'll again go for 192 only. Okay, so 192, 168. Okay, 192, 168.0.0, and then I'll end with 3. Here we need to have total of 64 IP addresses. So 64 IP address, the last IP address will end with 192.168.0.63. Okay, so the IP address subnet will be 192.168.0.0/26. Similarly here it will be 192.168.0.64. It will be the next number after the ending number here. So here it ended with 63, so this will start with 64, and I have to write the 27 CIDR value here. This is the CIDR value. I'll write this here. So the first number will be 192.168.0.64, and the first 4 address will be reserved, and then the last address. How to find the last address? 64 plus 31, which is 95. So 192.168.0.95 is the last IP address. So the next subnet will start with 192.168.0.96 slash, what is the CIDR? /28. Okay, now this is how you'll be writing down the remaining numbers: 96, 97, 98, 99. First 4 IP address will be reserved. Last IP address 96 plus 15. I mean, since I'm starting with 96, I cannot add 16. I will have to consider only 15. So 96 plus 15 is 111, 168.0.111. So this is how we need to identify the total usable IP address. Now we will go and find out the subnet mask. How to find that? You have to just copy paste the CIDR value, and then I'll have to write it in the bit format. Okay, 8, 8, 16, 24, and then this will be 2 bits. Okay, 26. 8, 16, 24, 3 bits, 27. 8, 16, 24, 4 bits, 28. Okay, now the subnet mask will be 8, 8, 16, so 2 bits, right? I have to add these 2 bits, which is 192. Okay, I have to add 3 bits. Okay, 1, 2, and 3 bit. The sum is 224. Okay, 224. Okay, I have to have 4 bits here. 1, 2, 3, 4. 4 bits is 240. Okay, so I've got these 4 bits here. Okay, now we have completed the subnetting calculation. So overall, how many IP address I need? I have to add all these total here. So I've got 64 plus 32 plus 16. Total of how many IP address? It will be total of 112 IP address. So that is the overall IP address requirement. Okay, 112 IP address. So for 112, so I'm having 128. Okay, so 128 is the formula. 2 power 7. 2 power 7 is 128. So we need to find out the CIDR now. So how to find out the CIDR? 32 minus 7. Anything on the next to the power is what you have to subtract. 32 minus 7 is /25. Okay, /25 is the CIDR value. So how do we write the overall subnet requirement now? So it will be 192.168.0.0/25. Okay, this is the overall IP address requirement that we have. Okay, now let's go and do this in the AWS platform. Let's go and create this in AWS environment. Okay, so here in AWS, I'll go to the VPC. First, I have to create the VPC now. I'll have to go and create the VPC, and I'll say the name tag is, what is the name we thought of giving? So we thought of giving XYZ, right? So I'll create XYZ VPC 01. Here, I need to give the overall IP version for CIDR. Okay, 192.168.0.0/25. Okay, and I'll scroll down and I'll create the VPC now. So first I have used the number from here to create the VPC. 192.168.0.0/25. I've used this number to create the VPC. Now I'll have to go and create 3 different subnet using these numbers. Okay, so these are the subnet range. Okay, I'll have to create subnet using these numbers. Okay, go to subnet. I'll create subnet now. So here I have to select the VPC that I have created, XYZ VPC01, and now I have to create the subnet for my requirement. First subnet is web subnet. Okay, I'll copy this. I'll just call this as web subnet 01. And what is the IP address requirement? The IP address requirement is 192.168.0.26. Okay, I'll paste this, and I can add as many subnet as I want. So I can just go and add the next subnet, app subnet 01, and I can copy the range. Okay, and I can also create one more subnet. I mean, as you can create as many subnet as you want. Okay, this one I'll call it as db subnet 01. Okay, so here I'll add the range 192.168.0.96/28. Okay, now I added all the 3 subnet, and I'll just say create subnet. Okay, so once after I create, I can just go and verify how many usable IP address. See, we already identified that, right? So here the usable IP address is 59. So we can cross check that. So here I can also see 59 usable IP address. Similarly for this one, I've got 27 usable IP address. So here I'm getting 27, which is the same that we planned. Similarly here, I've got 11 usable IP address. Okay, that is what we expected, and we have got 11 usable IP address. So whatever formula we did, whatever we did in the calculation, it is matching the AWS field there. Okay, I'm getting the expected output. Okay, I will be using 2759 usable IP address from each of this range. So now let's go and do one more thing. So now I need to go and create the server using this VPC and subnet. So how do I do that? I can just go to EC2 now, and when I create the server, okay, when I go and launch the instance, yesterday we did not select anything on the network level, but now since we have created a separate VPC, we have to go and update the network settings with the VPC that we have created. So if I want to create a web server, I'll have to go and select the VPC that I've created, XYZ VPC01, and I have to select the specific subnet. Okay, web subnet or app subnet or DB subnet, whichever subnet you want, you can go and create it. For example, if I want to create a server in web subnet, I can choose the web subnet, and I can just give the name as XYZ web server 01. Okay, now for this machine, which IP will be allocated? It will allocate the very first IP from the range. So if you look at here, the very first usable IP address will be 192.168.0.100. 100 will be the first usable IP address for the system, because the first 4 IP is reserved by AWS for network address, gateway, and DNS and other services. Similarly, the second usable IP will be 192.168.0.101, and similarly it will go on up to 111. So let's see what IP address it will assign. So I'll create a key pair. So I'll say Paris 2022 September. Okay, I'll create a PPK and then create it. Okay, let me go and launch the instance now. If I launch the instance, let's go and check. See, it has assigned 192.168.0.45. So did we select the, okay. I think we selected the wrong subnet. We selected, okay, web subnet. Oh, okay. So the name, I've selected the web subnet only. So I've selected the web subnet and it has assigned the IP address in this range. Okay. So it can assign any IP address in this range. It has assigned 192.168.0.45. 192.168.0.45 is within this range only. Okay. It can assign any IP address within this range. Okay. 4 or 5 or anything within this range. So if I select the DB subnet and create a machine, it will assign a IP address within this particular range. Okay, let's go and create a one more machine in the other range. Okay, I'll call it as XYZ DB server 01. Now I'll just go and select the network. So here I will say I want to create my machine in my VPC and I have to select the DB subnet. So if I select the DB subnet and create the machine, automatically it will assign an IP address from this range. It can be any number from 100 to 111. Let's go and check that. Okay. So it has assigned an IP address 101. Perfect. Okay. So this is how you have to derive the calculation and you can execute the same in AWS. Okay, this is what they call it as subnetting. This is how you can plan how you want to create a network address space and how you want to create a set of systems and use the IP address from that range. Okay, so maybe let's stop the recording now and we can continue in some time.